Hello, yes, my name's David Ball. I'm going to be talking about robots and agriculture. I guess to start off with, I'm not an expert in horticulture. This is my first foray into it. I'm very interested in lots of feedback and finding out really, what you guys want, what you guys need. So that's I guess my primary purpose to come here. But I want to talk and review a little bit about some of the history of robots in agriculture really quick, really just cover a few of the approaches that have been started. But then on the other side, talk about some of the commercial, the successful commercial robotic type projects that have happened and what the common attributes of those are. Also talk about our ARC, Australian Research Council linkage project, the AgBot project as we call it, and the vision and approach of that. Okay, we're in very early stages of that. In fact, field trials just in 2 weeks, so we don't have any concrete results yet, but we're just getting underway on that. So I just want to talk about the vision of that and try and get buy-in from the horticulture side as well. Talk about the QUT Robotics Group, a very new group, as well as the future, and a very exciting future that we have. I'd also like to introduce Andrew Bate. I don't think he's here. He is the partner investigator on this project, one of the passionate, sort of inspirations behind this project. He is around. I'm not sure if he's here in this venue. I think he was doing an interview outside. But the director of Swarm Farm, and the partner investigator, one of the investors. So he's out there. And that's really been a big driver behind, I guess, the success of the development of this project, is having rather than just the university doing it, having an actual farmer there constantly that I can pick up the phone to and talk to weekly and ask questions and go up and get data from the farm. That has been really useful. There's also Salah here. I didn't know he was going to be here, who is the director for ACFR. And so you can chat to him as well. So I guess a couple of approaches that have been made to field robotics or agricultural robotics is to take an existing platform. So you might have your vehicle or your tractor and you add a whole bunch of sensors and throw a whole lot of processing at it. This is certainly an approach that has had quite good success with moving around the field. The question I think that remains is some safety issues, some bigger how this tractor sort of with the sensors on it fits into the whole farming ecosystem, and probably a cost issue. You've taken already probably an expensive tractor and added a whole bunch of expensive sensors. This has now increased the price of the robot vehicle. So that's probably some of the issues that need to be addressed in the future. The other platform, the other approach that seems to have been taken is probably more from the European side, and that's to start from the ground up and build the platform bit by bit. Probably one of the disadvantages of these approaches, if you look at this robot here, it's very complex. There's lots of moving parts. The robot can move up and down. The wheel tracks can move in and out. It can move in all directions. Commercializing this type of platform, again, there's a cost issue here that needs to be considered, and probably a robustness issue as well. So that's another of the approaches we have, probably more out of the European side of robotics and agriculture. I looked around for robot manipulation. There is robot manipulation for orchards and that. But this is probably the best combination of robot and manipulation there is. That's using the humans to do the actual grabbing the fruit, okay, and putting it into a bin, and having the robot, there's no driver in this vehicle, having the robot drive itself up and down the rows. Manipulation is an extremely hard task. You can't just grab an industrial robot. They are very precise in how they move, but most of the time when you're doing tasks like this, you need to be much more of a force control. You need to apply not just the position, but grasp it gently and pull it gently. You don't want to damage the fruit as you grab it. And also, it's not in a very precise location as well. So this is probably one of the best examples from the US that they're currently field testing quite successfully at the moment. The other one that's been done is at the same time as you have these robots moving around, you can use them as a sensor network. Okay, so if you have numerous robots around, they can be gathering data that you can constantly being fed. And this is from, again, the US. Steve Nuske was actually from Australia, who's moved over there as a research fellow. And basically at night, his camera system goes along and takes images of all of the apple orchard and then using some advanced image processing techniques, he segments out where all of the apples are. Okay, so that's what's on the left side. On the right side is a comparison between what his system says that the yield is across this orchard field compared to what they had a whole bunch of students hand count. And you can see that the accuracy is pretty close. It's definitely a usable yield estimate. So this is really useful, not just actually doing the harvesting, but getting information, up-to-date information from the farm as it's happening. Okay? So I guess as a summary, I just got back from the International Robot Conference in Germany. Probably, I think maybe 1,000 papers, not a single one in robotics and agriculture. Lots in medical, lots in sort of aerospace, lots in indoor robots, not a single paper in agriculture. That's interesting. I've got to go back and think about why that is. Potentially innovation is stalled in this space. Potentially it's reaching the commercialization cusp. I need to think about that a little bit and have some conversations with people. There used to be more in the conferences, but not a single paper this year when I went along. And that's significant. So what we think, we need more innovation, we need more conversations with farmers, government, researchers, manufacturers, trying to combine everybody together and work from the ground up for a solution. Just to talk about some successful commercial systems, robot systems. This is probably the most successful one, the vacuum cleaner. I certainly have a robot vacuum cleaner. How did they get it successful? They started with cost. They actually went away and had a look at what a partner, as in a spouse, could spend without having to consult their other spouse. What sort of leeway they had to put on their credit card that they could purchase without having to have any consultation. And they worked out that in the US, years ago, that was $200. That is the original inspiration for it. They didn't start with, oh, let's build a platform, research platform, and do a whole lot of work. They started with a cost. And so that was significant. They also spent a lot of time making it simpler. If you have a look at the robot at the top, which was one of the early Roombas, it had 4 buttons. They ended up with huge amounts of phone calls. Which button do I press? What's a large room? What's a small room? And ultimately, over time, they've evolved it so there's 1 button to press. And this is important because they've deployed the robot platform, but then they spend a lot of money supporting it. Now that they've made it simpler from a usability point of view, they don't have to spend all that money. So that's a successful project. Where have they moved to from there? The same person has moved out of robot vacuum cleaners into industry, into manufacturing, trying to corner the market in that space. Cheap manufacturing is becoming scarcer. It's not really in China anymore. Those costs have tripled recently to get things produced there. So they've produced this robot called Baxter. It has cameras in the arms, it has cameras in the head, and it can do simple manipulation tasks and be taught very easy. You don't need to be a programmer to use it, you just show it how to do it. And you can buy this today for $22,000. And there's a lot of robot development happening on this platform at the moment. One of the key features of it is not a precise system. It has springs in it so that it has some sort of give. There's videos of children climbing over it while it's working. It's safe to be around. They designed it from the ground up to be that way. So it can work in amongst people. Another very successful one is Kiva robot systems. These have just been bought out by Amazon to do their distribution centers. Again, they started with really, really cheap motors, cheap batteries, cheap platforms, and then built a lot of intelligent smarts on top of it. And as you can see on the video, again, the manipulation task, which is currently hard when they started it, has been done by the humans. So the robots bring the packages to the humans, they do the pull out of the box and put it in the next box to be sent to the customer. What's one of the problems that we have when we get phone calls? It's the media has distorted the term robot. One way, Transformers. That's really big overhype of the term. Okay, we're not anywhere near approaching that level of sophistication in the robotic technology. On the other side, you've got things like robot wars. These are not robots. Okay, these are remote control cars that they've added some bits of attachments onto. So we sort of have to stay somewhere in that space and constantly combat against that. And just last week when I had a phone call from a farmer, he sort of had, we've got the GPS waypoint following, we've got the tractor, I just need to buy the robot module. Could you give me a bit of feedback on where I should go and buy that and how I just fit it in? It's not that easy, okay? We're not at that stage yet in robotics where you can just buy it and plug it in, okay? There's still a lot of development that needs to happen. The reality for just adding the robot piece is probably closer to the middle, but I think the better solution is to really start from the ground up and build an integrated solution. And yeah, don't just start with a tractor, but start from the ground up and think about what you really need. And think about it, as was brought up in yesterday's meeting, maybe selectively grow the plants so that they are at a different height or they're easier for us to manipulate and grab off. Think about solution differently. Current trends in robotics at the moment, lots of code being freely available at the moment, lots of people publishing the code. They've got to prove it by publishing it, not just put it in a paper that never gets used again. Actually get it out there so you can test it yourself, and that's key because things are becoming more robust that way. There's this concept at the moment to move from automation, okay, so make something work for an hour, through to persistence, make it work forever, so it continually learns and adapts to the situation, so you don't need to modify it. And that's going to be a key thing in the future. You don't want to constantly have to update your robot. You want it to learn and adapt as it goes through. The other thing that's really significant is the smartphone market, what it's doing. Your smartphone now has quad core on it. It's nearly more powerful than your laptop. GPS sensors, inertial sensors, all of the cameras. You get cameras for $2 now. They're all drastically going down in price. And that's a key driver for robotics. Okay, we're sort of riding on the back of this cheap sensors and computation. So I'll bring to our actual project, which is Zero Tillage Agriculture, Robotics for Zero Tillage Agriculture. Combines ACFR from University of Sydney and Swarm Farm Robotics with Andrew Bate, who's just come in the door. He's keen to chat, very passionate, keen to chat about the project. About $500,000 project that we have going. What's the motivation for this? The current trend in broadacre is this sort of larger, heavier vehicles to increase productivity. Okay, it's this push to increase productivity in this method. Use GPS waypointing, become more and more precise, go down exactly the same track. The problem with this is it's led to the hyper-compaction of the soil, not usable easily again, expensive single points of failure. Okay, you've got this more and more expensive platform. What happens when it breaks? Okay, you're out for a couple of weeks. And the GPS itself isn't really smart enough for driverless farming. Okay, you need more than just GPS. So the vision of the project is to revolutionise farming by replacing this one expensive tractor, which needs a farmer still to sit in it while it goes backwards and forwards, with numerous cheaper, smaller robots that are intelligent, that work under the direction of a farmer. We don't want to replace the farmer. We still need that expertise in, what spray to use and all of those parts. But the robots themselves can go out and do the backward and forward down the rows. So the approach that we're taking is these, again, numerous small, cheaper robots that can work 24/7, not just daylight hours, not just night, but across the whole time. Get it back on the field much quicker after rain events. I guess we're applying this to weeding, so we want to get it out on the field much quicker so we can kill the weeds before they grow. We want to build an autonomous docking system so that the robots you don't have to maintain them. Okay, they just come back, recharge, and then go back out. And also multi-robot coordination so that they continue to adapt. And if one robot fails, the rest of them just pick up the slack. Again, combining cheaper sensors with novel intelligent algorithms and perception, and this smart robustness over fragile precision. So rather than fragile state machines, fragile methods that have been tried in the past, try these more broader techniques that we overlay multiple levels of consideration that the robot might make on what to do. And as I said, applied to weed destruction at the moment. We've recently had the Premier from Queensland come up and have a look at a demonstration at QUT. Actually, he didn't have to come very far, he just walked down the path. And so that's the team there we've got some PhD students, postdocs, professors, partner investigators along, and the Minister for Agriculture and the Premier. So this was a video produced by QUT. This is the professor of head of school at QUT. And this just shows a little bit of the robot moving around, no hands, moving around. One of the interesting things was the amount of OH&S I had to go through to have this robot drive around sort of in the city, around on a path where there's lots of people. Very interesting challenge, moving around. And we actually managed to, that's Gordon just showing inside the computer. That's the computer there. And that's the Premier. Really knowledgeable technically. He knew exactly what we were doing, and he wanted to know every detail of it. We managed to get him in it and drive him around, and both of them in as well. So that was good. That was a good success. Project status, as I said, 2 weeks we head up for field trials. Very exciting. This is going to be a good chance to test some of the algorithms that we've been working on and get a whole lot of data. And most importantly, I think have a lot of conversations with Farmer while we've got the platform there and try and develop it while we're there together. Just to talk a little bit about the QT Robotics Laboratory, it's really new actually. It was only formed in 2010 by Professor Gordon Wyeth and Professor Peter Cork. And the driving goal, as you can see, QT's motto is for the real world, a university for the real world. We want to do robotics for the real world, not just toy stuff, stuff that actually counts and is going to matter. And a lot of that is out in the field. We do work across air and land. We have some water robotics as well, underwater. Huge amount of space to map underwater. And we do indoors and outdoor robotics as well. The growth has been fast. 2 professors, 5 academics, 4 postdocs, and 17 PhD students. We're definitely growing out of our space that we've already got there. And that doesn't count our ARCA group, which I'll talk about in a sec. That's our aerospace group. So Peter Cork comes from one of the key drivers of automation in mining robotics as part of CSIRO. He was one of the key people who set up the QCAT group there that did automation for it. And one was the LHD, which is a really large truck driving through the tunnels. And the other one was automating the dragline, one of the world's largest robots, and making it autonomously, dig out there. So he's come across to QUT, and now we want to get into the agriculture space. Other things that we've got going, vision-only mapping of a suburb. There's no GPS involved here. This is purely using a camera sensor. In fact, this is one of the laptops strapped to the top of a car with some tape, and the little camera that you've got that you normally use as a presentation for doing our webcam chats. That's it. Okay, and all the system running on that laptop. So it's vision-only navigation. These camera sensors are really, really good if you know how to process them. We have many more robots. We've got UAV robots, underwater robots, these indoor robots as well. A lot of the focus on the indoor robots, as I mentioned before, is about going from this short-term automation towards long-term persistence. So we've got docks there now built so that they can come back and recharge, as well as getting into sort of more the legged robots. Our world is built for we've evolved and our world is with us for our human shape, for legs. A lot of the terrain is very difficult for wheels to get over, so legs are going to be one of the future research areas. Just to give a little bit about ARCA. ARCA is this sort of 6 million purpose-built facility out at the Brisbane airport to focus on aerospace. They have a huge number of projects that you can see a list of there, a lot of funding coming in. They work closely with a whole lot of partners on these projects. And they're really interested in sort of surveillance as well as automating planes. One of the projects that they have I think done or they're doing, I'm not sure exactly, is this Biosecurity project where they have their Cessna plane that they fly around. It has a spore trap on top. The plane flies around autonomously in a good path and then collects this. And it's really about this biosecure project, okay, monitoring what's happening. I don't know too much of the details of that, but yeah. What's the future? Right now, in fact, just yesterday, the Premier was impressed with the project, so he wants us to put in a proposal to expand the AgBot project. This just happened yesterday. 3 key things we want to expand into. Smart technologies for horticulture, so looking at the automation side of it, crop monitoring for yield, so that you can monitor that. And this is part of, I guess, sensor networks. And the other part is pest deterrence. Imagine a whole bunch of UAVs that when crows come in, they just fly them off and chase them away. That that's the type of deterrence that we want to add into the system. Alternative energy robotics. So rather than diesel, potentially look at solar-powered, other energy sources that are renewable, as well as self-contained methods of destructing the weeds. These are robots then that never come back. You just leave them out in the field and they just continuously shock, dig up, whatever the best approach is to get rid of the weeds, and they're solar-powered or however they're powered, and they just move along and they just do their task forever. The other thing that we've got, and want to put a key person on this, is the legal, society, safety, and training issues. They're really important, right? Who's to blame if something goes wrong? Need to work these issues out. Safety, not only for the humans, but also for the robot. You don't want to put your $100,000 robot out that's doing this and have someone come and steal it. So we need to work out safety both ways. And this is becoming a big problem that we're talking about in the robotic circles. What are we going to do about this? So we need someone on that to start looking at that right from the start. And just to finish, to complete this picture, and I guess one of the reasons I'm here, we do need to talk to field equipment manufacturers, right? The people that are actually going to manufacture equipment. Horticultural farmers, that's you guys. What do you need? What do you think is important? What should we be addressing? Okay, we're just starting to develop it now. Please let us know. And also those that are interested in the manipulation task, which is a really challenging task, but we want to get into that space and do that. Thanks.
Look, thank you very much for that, David. We'll throw it open now for 5 minutes just for questions, just have a little bit of interface. If you don't get time to actually ask your question in this 5 minutes, just write it down and we'll do it at the end after all the presentations. Thank you. Who wants to lead off? Well, dumbfounded. What's wrong? There must be someone. Danny, yes. We've got some roving Moics, so if you just want to actually just state your name and where you're from, it'll give us our diversity of the meeting.
My name's Danny Diazzo. I'm from South Australia. I'm a grower. Also sit on the IAC. As we spoke about yesterday in that meeting, the robotics, I like to see it developed for intense horticulture, similar to obviously the automotive style of robotics, but for field use. And you were saying you develop a springs or touch sensory. So obviously with, I suppose, cameras and optics and all that sort of thing becoming more affordable, I think that we should look, I like the idea of that vacuum cleaner cheap, where we could make it affordable for our industry, because I see wages for intense horticulture a problem. And I'd like to obviously get rid of as many staff as possible. So, yeah, so I'd like you to think about intense horticulture.
Absolutely. I think the Baxter robot is a good sort of approach that we can have a look at first and work from that type of principle, right? They started from the ground up building a cheap platform that could manipulate and work amongst people and do those type of tasks. I don't think it's very waterproof, but that might not be a problem. There's a robotics project for like a greenery where rather than moving the robots to the plants, they move the plants to the robots. They keep them in the little pots and move them around. So that's the type of approach, like if we start from the ground up with robotics, we can think about. Absolutely. Very interested in that space. Very interested.
Another question?
Jesse Reader, Apple and Pear Australia. I'm just interested, there's a lot of effort going into the technology, and that seems to be the limitation and the cost of the sensing. How much is actually being done into looking at the system, and how much we should be actually perhaps modifying the system to suit the technology, and that, you know, it's happening quite quickly now, and which one's going quicker? Is the system going to beat the sensing by the time you get that part right, or which, you know, how do you balance where you put your research into?
I'm not sure exactly how to answer that, but I think we should start from the ground up and think about what we really want and design from a cost point of view. What we think in 5 years, is going to be cheap computation, cheap sensors. Have a look at the drivers. Smartphone market is a good example, and see what's going to be cheap there. In Australia, most of the robotics work is in perception. We're trying to move away from, I guess, using lasers, which only give you this one scan line and are still expensive for outdoors, towards using vision. Vision gives you all of this information here. There's a reason we've evolved vision sensors. And a lot of the problem though is it's so much information, and we still don't really have a robot system that can say, identify that these are chairs. So that's where we're working. Perception, mainly based on vision, I think, will be the key driving. And that's also combined a lot of, there's a lot of groups out and around Australia and internationally that are computer vision groups. And all they do is use cameras, relatively cheap cameras, and they're trying to push that space, trying to work out the world, how everything fits together, and move around with vision only. So as roboticists, we can tap into that and use a lot of the algorithms that they've developed.
David.
David Moore, Horticulture Australia. David, with the adoption of most technology, it's all around how time intensive the technology is. Most of the research shows that. Is having multiple smaller robotic equipment going to require more time intensivity from the farmer relative to one unit? So driving multiple units, is that going to be more time intensive? And if it is, it may not likely get the adoption.
That's a really good question, and actually Salah might be better to answer that because they're working on that coordination part of the system, coordinating the multiple robots so if one fails, the others take over. And starting, I hope to look at some of the usability issues. So, it's useless having a very complex system that the farmer needs to spend months training. It needs to be something where you just pick up, you download the app, you look at it, and you can see what's happening, and very simple to use. Usability is so important, and I think that's part of that societal, legal, safety issues. You start looking at that right at the start. That's so key. It's no point building a complex system that no one can use. It has to be designed to be easily visible and usable. Yeah, and that's shown like for the robot vacuum cleaner. 4 buttons was too complex for the consumer. They had to go just down to 1 button. Yeah, absolutely.
Well, if there's no further questions, we'll thank Dr. David Bell for his presentation, if we may, and we'll move on.